Hi guys, we're starting chapter 4 and we're going to be talking about factoring. And today we're going to look at a couple of topics that are used in factoring that we need to review. And first of all is greatest common factor. So that is going to be the first step in factoring a lot of times is taking out the greatest common factor, or we say factoring out the greatest common factor. So example 1 is just that. Factor out the greatest common factor from each expression. So we look at this first one, A. We have 2x plus 10, and we want to find what's the GCF, we call it, greatest common factor. It has to be a factor of both. We want the greatest thing that's the factor of both. We have to look at variables, and we see that there is the variable x in the first term, but the second term does not have any x's at all. So we know our common factor will not have x because we cannot factor an x from the second term, which is just 10. So we only will have to factor out a number. And we look at it, we check, will 2 work? Is 2 a factor of 10? Yes, it is. And 2 is as great a factor as you can get from the first term, right? Because the first term is 2x. You can't take a number larger than 2 out of that. So since 2 is a factor of both of them, and it's the largest factor we can get from the first term, we know that's our greatest common factor. And again, we know we cannot factor out any x's. So we have to see what's left after we divide by 2. So we can divide each term by 2. Okay, and that will give us, the first term 2x divided by 2 just gives us x, and then 10 divided by 2 gives us 5. Okay, and that shows what's left when we factor out the 2. But of course we have to write down the 2 as well, and now we've factored this into a product. 2 times quantity x plus 5. And that is our answer. We've factored out the greatest common factor. Now, this is just begging to be checked. We can check these so easily. So whenever you factor, usually it's when you factor out the greatest common factor, it's pretty easy to just check it. So we just multiply this out and see if we get back the 2x plus 10. So we take 2 times x is 2x, plus 2 times 5 is 10. There it is. Okay, it checks. Okay, so just something to do if you want to make sure you got it right. Okay, so let's look at the next one. We have 36x to the fourth plus 12x squared. Now this time we do have the variable in both terms. Okay, so we will be able to factor out x squared because that's the exponent of this one, and the other one has a larger exponent, x to the fourth. So we can factor out x squared from both of them. And then as far as the number goes, we see the smaller number is 12. So we ask ourselves, well, can we factor out 12 from the other number? And we can. 12 does go into 36. So 12 will be our greatest common factor. Okay. So that will be the number part. Okay, 12, and then we said we could take out x squared. So 12x squared is actually the greatest common factor. So we will divide each term by 12x squared to see what is left after we factor that out. Okay, and we get 36x to the fourth divided by 12x squared 36 divided by 12 is 3. X to the fourth divided by x squared is x squared. Okay. Subtract exponents. 4 minus 2 is 2. So it's the exponent is 2. And that's the first term. The second term, 12 divided by 12 is 1. X squared divided by x squared is 1. That's just 1. Okay, and we factored out 12x squared, so we write it out front. And again, the thing is just screaming at us, check me, because it wants to be checked. It's very easy to check this, so let's do it. We take 12x squared times the first term, and 12 times 3 is 36. And then x squared times x squared is x to the fourth. So that part checks out. We got 36x to the fourth, right? So then we'll take 12x squared times 1. That's 12x squared. That's what it should be. So it checks. So that's our answer. Okay, we factored out the greatest common factor. Okay, we have one more, this great big problem. Wow, what's the GCF of that? Greatest common factor. Well, we look at each term. Now, we look at the variables, and the first, second, the third term all have A's and B's both, but the fourth term only has B. So we know we cannot factor out any A from everything. A will not be part of our greatest common factor because A is simply not common to all of these terms, right? There's no A in the last one. We won't be able to factor out A at all. But we can factor out B. It looks like there's some B's in all of them. The lowest exponent of the B is B squared right here. All the others have a higher exponent. So the greatest common factor will have B squared. And the number part of it will be whatever the greatest common factor of these coefficients are. We have 6, we have 3, 9, and this is just 1. Well, that tells us this is pretty easy because the coefficient of that last term is 1, and we can't factor anything out of that. So, again, to be a common factor, you have to be able to factor it out of everything. We could factor 3 out of all the other terms, right? We have a 6, we have a 3, we have 9. We could factor 3 out of each of those, but we cannot factor 3 out of the last term. And the only thing we could factor out of that is 1, which is trivial. It's really not doing anything to factor out of 1. So that's it. And we could write down here 1 just to show that it is 1b squared. But again, we don't even need to write that. Just b squared. Okay, so we'll divide each of these by the b squared. And you can do this in your head for a lot of these, but we're just writing it down to make sure it's clear what we're doing. Divide each term by b squared. Let's see. I think I got them all. And let's see what we get. So we have 6a to the fourth, and then the b cubed divided by b squared, that's just b. Okay, we look at the next term. this time I'll go ahead and write our b squared out front before we start. Okay, because we're dividing each term by b squared to get what we have after we factor out b squared, and then we of course multiply b squared times that entire sum after we've factored out from each term. So let's see, the next one is 3a. And then b to the fifth divided by b squared is b cubed. The next one, we have the 9 is there. 9a, that's all right. The b squareds cancel. So you just have 9a. And the last one, b to the sixth divided by b squared, that leaves b to the fourth. Okay, this can be checked again. Multiply this out, and we should get back to this, right? So the first one, when we do that, we have 6a to the fourth. We're going to have b squared times b, which would be b cubed, so that looks good. The second one, we'll have negative 3a, but then b squared times b cubed, that's b to the fifth, so that's right. The third term has the 9a times b squared. There it is, 9a b squared. And the fourth term, when we multiply it out, b squared times b to the fourth, that's b to the sixth, just like it should be. Okay, so it looks like it checks, and so that's our answer. We factored out the greatest common factor. Okay. So that's all of the factoring of greatest common factor we're going to look at. Now we're going to look at FOIL, first, outer, inner, and last, multiplying these binomials. When I learned this way back in the day, we didn't use this acronym FOIL. We just said, well, you're going to take the first term in the first set of parentheses and just multiply it by the others one at a time. And then you're going to take the second one and multiply it by each of the others one at a time. So that's the way I learned it, but we have this useful acronym FOIL, which stands for first, the first times the first, and then outer. O is outer, meaning the outer ones, that one and that one. And then inner, the I is for inner, which means that one and that one. And then L for last, so you take the 7 times the 1. And it's actually the same order that how I learned it. Turns out to be the same. And it works exactly the same. So we will do that on these examples. So do the first one, that's the 3x. I think, and I will go ahead as we go and write the arrows in. Okay, so we have 3x times 2x, that's 6x squared, right? And then we have 3x times 1, which is 3x. Then we have 7 times 2x, which is 14x. And we have 7 times 1, which is 7. So then we just have to combine like terms. 3x plus the 14x is 17x, and that's it. Then plus 7. Okay, so let's look at the next one. Again, we just take x times 3x is 3x squared. X times negative 5y is negative 5xy. And then 2y times 3x is 6xy. And then 2y times negative 5y, negative 10y squared. Okay, and now we combine like terms, which is these two middle terms. We have 3x squared minus 11x, nope, not 11, plus 1xy. And then that's the only thing we combine. Write down the rest of it like that. Okay, so we have one more. Let's do it. Take the 2x times 2x. That's 4x squared. 2x times negative 5 is negative 10x. Okay. And then we take 5 times 2x, and that's plus 10x. And then write this one down here. 5 times negative 5 minus 25. Okay, and then we have middle terms to combine. So we have 4x squared. Negative 10x plus 10x. Well, that goes away. That's 0. So that's it. Okay. So, the FOIL, multiplying these out by the FOIL method is really not a factoring operation. Taking out the greatest common factor like we did at the beginning is a factoring operation, but multiplying out is sort of the reverse of factoring, right? But we still want to review this. That's why we did it, because this will be used in factoring, and especially just to check your answers, right? If once you factor something and get the two binomials, you can multiply them together to check it. So that's all for now. We'll get more heavily into the factoring tomorrow.